Nakamoto Coefficient explained, decentralized are Bitcoin, Ethereum, and BNB Chain. Intro. Everyone in crypto talks about decentralization. But how do we actually measure it? Today, we are breaking down one of the most important metrics in blockchain analysis, the Nakamoto Coefficient. In this video, you will learn what the Nakamoto Coefficient is, what data is used to calculate it, the Nakamoto Coefficient of Bitcoin, Ethereum, and BNB Chain in 2026, how this metric is used beyond blockchains and its limitations. Let us start from the basics. What? The Nakamoto Coefficient. The Nakamoto Coefficient measures how decentralized a blockchain or decentralized system really is. In simple terms, it answers one question. What is the minimum number of independent entities required to control more than 50% of the system? These entities could be mining pools in proof-of-work blockchains, validators or staking providers in proof-of-stake blockchains, or voting wallets in DAO governance systems. If only a few entities are needed to reach majority control, the network is more centralized. If many independent entities are required, the network is more decentralized. A higher Nakamoto coefficient means stronger decentralization. A lower Nakamoto coefficient means higher centralization risk. What data is used to calculate the Nakamoto coefficient? The Nakamoto coefficient is calculated using control concentration data, and the data depends on the type of blockchain. For proof-of-work blockchains like Bitcoin, the data includes mining pool hash power distribution and the share of total hash rate controlled by each pool. For proof-of-stake blockchains like Ethereum and BNB Chain, the data includes validator or staking provider distribution and the percentage of total stake tokens controlled by each entity. Other data sometimes considered includes governance voting power, token ownership concentration, client swear diversity, and node operator distribution. To calculate it, entities are ranked from largest to smallest by control. Their control is added together until it crosses 10%. The number of entities required is the Nakamoto coefficient. Nakamoto coefficient values into 2026. Now let us look at world examples. Bitcoin. Bitcoin uses proof of work, so its Nakamoto coefficient is based on mining pools. As of 2026, just 3 major mining pools control more than 50% of Bitcoin's total hash power. Bitcoin Nakamoto coefficient is approximately 3. Even though Bitcoin has thousands of nodes, mining power is still highly concentrated among a few pools. Ethereum. Ethereum operates on proof of stake, so the focus is on staking providers. As of 2026, large staking entities such as Lido, Coinbase, Binance, and a few others dominate staking. Between 2 to 5 entities can reach over 50% of total staked Ethereum. Ethereum Nakamoto coefficient, approximately 2 to 5. This shows that despite having thousands of validators, staking power is still centralized. Chain. BNB Chain uses a validator-based consensus model. As of 2026, around 8 validators are required to control more than 50% of the network. BNB Chain Nakamoto coefficient is approximately 8. This makes BNB Chain more decentralized than Ethereum in validator distribution, but less decentralized than Bitcoin in theory. How else? The Nakamoto coefficient, USD. The Nakamoto coefficient is not limited to Layer 1 blockchains. In DAOs and governance systems, it is used to measure how many wallets can pass or block proposals. Many DAOs have very low coefficients, meaning a few large holders control decisions. In Layer 2 networks and rollups, if a rollup has a single sequencer, its Nakamoto coefficient is 1. This highlights centralization risks in early-stage scaling solutions. It can also be applied to oracles, bridges, and validator committees to identify single points of failure. Drawbacks of the Nakamoto coefficient. While useful, this metric has limitations. First, it is as a snapshot. The value changes as validators join or leave, tokens move, and mining power shifts. Second, it cannot detect hidden ownership. Multiple validators or wallets may be controlled by the same entity. Third, it ignores geography and regulation, A network may be centralized on-chain, but be concentrated in one country or controlled by regulated companies. Fourth, one metric is not enough. The Nakamoto Coefficient does not measure client diversity, censorship resistance, or economic barriers to participation. It should always be alongside other decentralization metrics. The thoughts? The Nakamoto Coefficient helps quantify decentralization instead of just talking about it. It shows who really controls a blockchain, how vulnerable a network may be to collusion, and why decentralization is harder than it looks. However, decentralization is not a single number. It is a balance of technology, economics, governance, and community. Thank you for watching. See you in the next video.